So, we're all hearing that AI agents are the future. But what happens when these amazing, powerful tools just suddenly fail? In this explainer, we're going to break down this hidden reliability crisis in AI and explore a completely new way to make them genuinely accountable. It's a frustration I think a lot of us have felt. Your AI agent seems absolutely brilliant, and then out of nowhere, it fails spectacularly. This isn't just some random bug, it's a really fundamental reliability problem that's kind of baked into the way today's AI works. So, at the heart of managing these agents, you've got this feedback loop. A user gives a prompt, the agent does its thing, and these observer metrics are always watching. But here's the catch. Unlike, say, a calculator that always gives you 4 when you ask for 2 plus 2, AI agents are probabilistic. That means you can ask the same question twice, and you might actually get 2 different answers. And that makes traditional testing incredibly difficult. And that brings us right to the core of the reliability problem. See, we're not just dealing with complicated code here. We're trying to manage systems that are designed to work in messy, unpredictable environments. And as we're all finding out, the old rulebook for software testing, it just doesn't apply anymore. Because these agents are non-deterministic, their performance can actually get worse over time as the data they see out in the wild changes. It's a problem that we call drift. They can have all sorts of unexpected interactions with other systems, and like we said, a simple pass or fail test just can't capture the nuance of how they behave. So if the old rules don't work, what's the solution? Well, we need a whole new evaluation playbook. And it all starts with building a solid foundation of metrics that can actually measure what matters in these super dynamic systems. The best way to go about it is with a structured approach, right? You move from these high-level goals all the way down to a constant feedback loop. It's not about doing random spot checks. It's a systematic process of defining your goals, gathering the right data, and then using that data to basically coach the agent. This is how we start to measure performance in a way that actually means something. So let's start with the absolute basics. You ask the agent a question, and you check if the answer is correct. Sounds simple, right? Well, in the world of language, what correct means is surprisingly tricky. Gata load this. Perfect example. The agent says, the capital of France is Paris. The ground truth, the correct answer we're testing against, is Paris is the capital of France. Now, you and I both know they mean the exact same thing. But a simple literal text comparison, it would mark the agent's response as a complete and total failure, a 0. And this is exactly why we have to go way beyond simple text matching. We need more advanced techniques that measure semantic similarity, the meaning behind the words. This includes stuff like keyword analysis, but also really complex metrics for systems that use retrieval augmented generation, or RAG, to make sure their answers are both true to the source documents and actually relevant to what the user asked. But you know what? Even these advanced metrics aren't quite enough. A correct final answer is just one part of the story. To really, truly evaluate an agent, we need to get into some advanced assessment and look at its entire decision-making process. This is where the whole idea of an agent's trajectory becomes so important. We need to evaluate its reasoning. Did it use the right tools? Did it follow a logical sequence of steps? We have to compare the path it actually took to an ideal path to see not just what it did, but how it got there. Okay, but what about those subjective qualities, like whether an answer was actually helpful or neutral? For that, we can use this really innovative and powerful technique called LLM as a judge, where we basically use one AI to grade another one. And the process is actually surprisingly straightforward. First, you create a super detailed rubric, just like a teacher would for an essay. You define exactly what a good answer looks like. Then you feed that rubric in the agent's response to a powerful judge model. What you get back is a structured score, a detailed reason for that score, and feedback you can actually use. So this puts LLM as a judge in a really interesting sweet spot. On one side, you've got human evaluation, which is the gold standard for catching nuance, but it's slow and super expensive. On the other side, you've got automated metrics, which are fast but can be kind of superficial. LLM as a judge gives us a scalable middle ground, combining the speed of a machine with a much more human-like way of assessing things. So why go through all the trouble of building this complex evaluation system? Well, because it allows for a pretty radical shift in how we think about AI, moving away from these simple agents to something way more powerful, contractors. We really need to shift our thinking here. Today's agents, they work off of these vague, short prompts, which makes them brittle and unreliable. The future, though, is this contractor model. It's built on formal, verifiable agreements that lead to accountable and much more deterministic results. And this isn't just some clever metaphor. We're talking about fundamentally changing the relationship between the user and the AI. Instead of just a vague request, you establish a formal agreement that has explicit terms, scope, and deliverables, all locked in before any work even starts. This contractor model is built on four really strong pillars. First, a formal contract takes the place of a simple prompt. Second, the AI can actually negotiate. It can flag risks or ask for more information. Third, its execution is iterative. It tests solutions behind the scenes to make sure they're good quality. And finally, for really complex jobs, it can act like a general contractor, hiring specialized sub-agents to handle different parts of the task. You can actually map out this whole life cycle. A contract gets submitted, but notice the first step isn't to just start working, it's assessment. The AI can then go into a revision loop to suggest changes, or it can accept the contract and start execution. This isn't a one-shot command, it's a robust dialogue that's designed to guarantee the final result perfectly matches what the user wanted. So when you get down to it, this contractor framework completely reimagines our relationship with AI. By building in principles of specification, negotiation, and verification right into the core logic, we can finally transform these unpredictable tools into systems that are truly accountable. And that leaves us with a final, kind of provocative thought. To truly trust AI with high-stakes, mission-critical tasks, we might need to start treating our interactions less like casual conversations and a lot more like legally binding contracts. The question is, are we ready to make that shift?